Okay, another calculus example. We're looking at number 6 from exercise 4H in the book. Find the coordinates of the point where the normal to the graph at x equals 1 intersects the curve again. Okay, so we're looking for a normal curve at x equals 1, but when it hits the graph again, so like we have some sort of function and then there's a normal curve. Okay, that was a bad example. Maybe this is the normal curve, and we're looking for this point where it hits again, this one being the one that makes 90 degrees. So, of course, we need to first find the normal curve, the equation for the normal. I'm calling it a curve. It's a straight line. So again, we're going to have like y minus y1 equals x minus 1, because I already know that the x coordinate is 1. I also know that I can get the y coordinate by plugging the x into the original function, and I know that this is going to be negative 1 over the first derivative of the function at the point x equals 1. So the function we're given is f of x equals x squared minus 3x plus 1. Okay, first of all, let's find this y coordinate. So like f of 1 is 1 minus 3 plus 1, which is negative 1. Okay, so I know that this here is minus 1, so it's y plus 1. And now I need to find the first derivative, plug in 1, and then use the negative reciprocal of that. So f prime of x is 2x minus 3. So f prime of 1 is 2 minus 3, which is negative 1. So my normal curve is y plus 1 equals negative 1 over 1. So it's just going to be 1 times x minus 1. This could be the end. It's a little strange to leave a coefficient of 1 there, but it's not the end of the question. So I'm going to rearrange this. We want to find where else this straight line cuts this curve. So we'll be doing that by setting the two equations equal to each other. Like we find the point of intersection by solving the system of equations. This is going to be easiest if I have y equals. So it's x minus 1 from the other side, so y equals x minus 2. Now I can solve the equation x minus 2 equals x squared minus 3x plus 1 to give me the places where these two functions intersect. And I expect there to be 2, because I know one of them is when x equals 1, but apparently there's a second point. So let's go ahead and set this equal to 0, because it's a quadratic. I subtract x, so I have negative 4x. I add 2, so I have 3. I prefer to solve things by factoring. I also, because this is a nice round integer, I expect it to be able to factor. In fact, one of the factors should be x minus 1. So this will be x minus 1 times x minus 3. So the two solutions are x equals 1 and x equals 3. This is the other place it crosses the curve. We double check the instructions to see whether I need to also find the y coordinate or whether this is enough. It says find the coordinates, plural, so I do need to find the y coordinate. So going forward, I need to find what is the y coordinate when the x equals 3. This is 3 squared minus 3 times 3 plus 1. These cancel, and it equals 1. So the points where this function hits again, the original function is a quadratic, so actually maybe consider just, it looks like this. Then I have the straight line coming through. Hold on, I want to know a little bit more about this function just so that I can draw this correctly. The axis of symmetry is going to be 3 halves. So x equals 1 is on this downward facing side. So then the normal curve is doing like this guy here. This is a right angle, and this is my point 3, 1. So the answer is 3, 1. The x coordinate is 3, the y coordinate is 1.